This week on the show, we tell you a little bit about the UNIX philosophy in 2019, why we use package managers, touchpads interrupted, porting Wine to AMD64 for NetBSD. That's interesting. We also have the second evaluation report for that, enhancing the Syzkaller support for NetBSD. We have a little bit more information about the Pinebook Pro, how to kill a process and all of its descendants, and fast software is the best software in this week's episode of BSD Now. BSD Now, episode 312. Why package managers? Recorded on the 21st of August 2019. Hello, I'm your host, Benedikt Reuschling.
And I'm Alan Ju.
Welcome to this week's episode. We thought of bringing you the usual things in the proper order. First, the headlines, as always. The UNIX philosophy in 2019 is something we should take a closer look at here.
Yeah, so this post says, earlier this week, I did a presentation for WWIT Pro that detailed the UNIX philosophy and its relevance today. Given the subject matter, I decided to do the presentation in PostScript on a Spark book running Sun Solaris 2.5.1.
Ooh, neat.
So it starts, what is UNIX? Simply put, UNIX is an operating system that was created by Ken Thompson and Dennis Ritchie in 1969, and eventually was rewritten to use Dennis Ritchie's C programming language. But Thompson and Ritchie worked at AT&T Bell Labs at the time, which couldn't participate on the software market due to tensions with the Federal Trade Commission. AT&T was a monopoly as the phone company at the time. So AT&T sold the source code for Unix off to different companies, which modified it to suit their needs, thus creating their own flavor of Unix. AT&T also gave a copy of the Unix source code to the University of California at Berkeley, who created BSD, the Berkeley Systems Distribution, a flavor of Unix that gained a lot of traction among other companies and universities, who in turn modified BSD Unix to their own unique version and often contributed those changes back. Unix flavors based on the original AT&T source code are collectively called the AT&T Unix family, while Unix flavors based on the BSDs are the BSD Unix family. And then the Linux operating system we see frequently today was derived from the Free Software Foundation's GNU project, which aimed to create an open source version of Unix because the AT&T one required an expensive license at the time. So what is the UNIX philosophy? If you ask the average person working in a computer-related field what Unix is, they'll likely mention the word simplicity. Of course, it's true that Unix is a simple, elegant, modular design has resulted in a system that is easily extensible and powerful. But is it really a philosophy? The UNIX philosophy is somewhat difficult to define, partly because it has changed over time to reflect certain virtues of Unix that emerged during its natural evolution. The main bits of the UNIX philosophy are collaborative development, rather than just doing it by yourself, simple, portable, and programmer-focused. The idea is that when you build something that follows the UNIX philosophy, it should work in all of the Unix-like operating systems.
Oh, yeah.
And it also had a focus on networking, which was a very new concept at the time. The first version of the UNIX philosophy was written by Ken Thompson back in 1973. And it said, write programs that do one thing and do it well. 2, write programs that work together. Hence, with the creation of something like the pipe, you really wanted to be able to take the data from one program and use it in another program. And being able to send data back and forth and handle that made a big difference. So step 3 of the UNIX philosophy was write programs that handle text streams because that's the universal interface. And, that's why almost everything on the command line is inputting or outputting text.
Yeah, very simple, and everyone can read it, whether it's a human or a machine.
But by the late 1970s, Unix has spread like wildfire and evolved tremendously as a result. So in 1980, Thomas and Ritchie summarized the major features of Unix as having a hierarchical file system and incorporating demountable volumes. While that sounds pretty basic, you have to remember that before this, there weren't really the concept of directories and so on. You just had all the files on your computer in one place. You just had a list of files. So being able to sort them and have file systems mounted on top or more than one disk was a big thing. And demountable volumes, being able to unmount some of the stuff and not have it all there all the time was interesting. Compatible file, device, and interprocess I/O, being able to copy the content of a device to a file, or a file to a device, and so on, or just actually being able to move information from one process to another. It didn't really exist before.
Yeah.
The ability to initiate asynchronous processes. If you've done much with the shell, you know that you can send a program off into the background to do work and not take over your terminal the whole time. That was a new concept.
Oh, yeah.
How would you do much on your computer nowadays if you could only run one program at a time and it was always in your face? You wouldn't get nearly as much done. The system command language selectable on a per user basis. The fact that different users can have different shell programs is a big deal. There are over 100 different subsystems, including a dozen different programming languages, and it has a high degree of portability, which back in the day where there wasn't a standard for what a computer was, and each new computer required changes to the operating system to work on it, we've kind of been spoiled by the age of the x86, where every computer is just pretending to be a really old computer that everybody knows how to work with. So this led Brian Kernighan, who contributed to AT&T Unix, to expand the UNIX philosophy during the 1980s. And his version was, number one, everything is a file. Number two, small single-purpose programs, meaning modularity. You can compose a command by combining a bunch of these different tools, like the spell checker and so on with pipes. Or number three, the ability to chain programs together to perform complex tasks. The pipe turns out was a big thing. Number four, avoid captive user interfaces. Most Unix programs are non-interactive, requiring arguments on the command line instead of user input, which makes them useful for scripting. Being able to actually write a script that says do all these things instead of somebody having to sit there and answer yes, no, no, yes, 5 a bunch of times. And configuration data is also stored as text.
Mm-hmm.
And it goes on. And so it's important to note that by the 1980s, Unix popularity had widely attributed to the simplicity compared to other software systems that existed at the time. David Tilbrook at the University of Toronto put it plainly, the one thing that has to be stated about Unix is that it wasn't a great advance in computing. If anything, it was a great simplification. It put into the realm of the users those things that were inconceivable prior to that. And it also resulted in John Gage from Sun Microsystems saying that the network is the computer.
Ah, yes, the famous Sun logo.
And it goes on and on. But in short, by the 1990s, it was quite clear that regardless of what Unix vendors wanted, the future of Unix was tied to open source and that form of software development. And this open source focus required a revision of the UNIX philosophy, which said that it should be modular, right? We have these small pieces that can be composed together. Clarity, because being clear is better than being clever, because it allows other people can work on the code as well. Composition, where you can string a bunch of programs together. Separation, let policies be changed without destabilizing the mechanisms. And that's kind of led to the FreeBSD philosophy of tools, not policy. We give you a bunch of tools and you decide which way you want to do it, rather than we saying you do it this way or it might not work.
There's no other way. Yeah.
Simplicity, design for simplicity, add complexity only when you have to. Transparency, design for visibility to make inspection and debugging easier. One of the things that I like so much about FreeBSD is the observability, being able to tell what's happening instead of it just kind of being this black box and you're like, I don't know why it's doing that.
Yeah, Control T.
Step 7 is failure. When you must fail, fail noisily and as soon as possible. This way, we know what the failure was caused by. If the failure is delayed and shows up much later, it's harder to tell what caused it. Have diversity. Distrust all claims of the one true way. Extensibility, design for the future because that will be here sooner than you think. And parsimony, write small, easily replaceable code that can be thrown away if needed. Don't be afraid to throw away large chunks of code if they're not very good.
Oh, yeah. That's also good points, yeah.
So yeah, an interesting presentation. And there's even more to it if you go and follow the links.
Yeah, we have that in the show notes. And now, for the namesake of this episode, why use package managers?
So this comes from the High Performance Computing Lab at the University of Wisconsin at Milwaukee. Especially in the kind of sciencey fields, you can really run into things where people, especially when doing science and so on, aren't really using package managers so much as kind of cobbling together bits of source code and so on.
Yeah, there's one way of doing that. So they ask, why use package managers? Deploy software in a small fraction of the time. Valuable research is often hindered or outright prevented by this inability to install software. This need not be the case. Since the author began supporting research computing in 1999, they've frequently seen researchers struggle for days or weeks trying to install a single open source application. In most cases, they ultimately failed. In many cases, they could have easily installed the software in seconds with one simple command using a package manager, such as Debian packages, FreeBSD ports, Mac ports, or package source, just to name a few. Developer websites often contain poorly written instructions for doing caveman installs, manually downloading, unpacking, patching, and building the software. The same laborious process must often be followed for other software packages on which it depends, which can sometimes number in the dozens. Yeah, we've all been there. Many researchers are simply unaware that there are easier ways to install the software they need. Caveman installs are a colossal waste of man-hours. If 1,000 people around the globe spend an average of 20 hours each trying to install the same program that could have been installed with a package manager, which is not uncommon, then 20,000 man-hours have been lost that could have gone towards science. How many important discoveries are delayed by this? So they told some of the features or the pros of software package managers. Flexibility, for example. Package managers that support building from source, like FreeBSD ports, Gentoo portage, Mac ports, OpenBSD ports, package source, etc. They also offer build options for many packages, so you can customize the installation to your needs. For example, below is a FreeBSD ports dialog for building and installing the R statistics package, which science folks always use because it can create nice graphs, among other things. So there's a lot of options to select, and this will pop up if you haven't done any options selection yet. There's also the massively parallel workforce. Maintaining tens of thousands of packages requires a lot of man-hours. Fortunately, there are thousands of maintainers working together on it, each benefiting from the work of the rest. They also eliminate redundant effort. Sadly, thousands of end users around the world often duplicate the same unnecessary effort trying to install a software package. If they all use the package manager instead, each package would need to be only created once and maintained by one person, while everyone else can deploy it effortlessly.
Yes, and then those people are now freed up to go maintain a different piece of software, and then all the software will be in the package.
Yes, yeah. So we have to definitely give a huge thanks to the people who are maintaining packages and providing them in the respective package managers. Every machine is expendable. Have you ever been in a panic because your server went down and you're approaching a deadline to get your analysis or models done? If you deploy the software with a package manager, no problem. Just install it on another machine and carry on. If you've done a caveman install, you might be dead in the water for a while until you can restore the server or duplicate the installation on another.
Yeah, the problem with the caveman ones is sometimes it's not really possible to duplicate.
What options did I use to compile this? Don't remember.
Well, not only that, it's just like, oh, it's a different version now, and the dependencies are different. So even if I wrote down everything I did before and tried to follow it again, unless I go find the old version of the software, I might be stuck. And that's the other thing. If you do a caveman install, you're heavily disenfranchised away from actually upgrading the software ever. Whereas if you have a package manager, you can get the newer version.
Yeah, exactly.
Now, when doing science, sometimes you actually want to stay, and that's an option. But at least it's an option rather than you're being forced to it because you just can't be bothered to deal with trying to upgrade it.
And then there's a section on why package source in particular. They talk about the features that package source provides, like portability. Most package managers are specific ones to a few or similar platforms. For example, Debian packages are used only on Debian Linux and derivatives such as Ubuntu. FreeBSD ports are used on FreeBSD and its derivatives, Desktop BSD, GhostBSD, TrueOS, and Dragonfly BSD. Mac ports are only for OS X. The package source package manager is unique in that it fully supports most POSIX-compatible Unix-like operating system. The package source is primarily the primary package manager for NetBSD and the joint SmartOS, But it's also well supported on other BSDs, the Linuxes, Mac OS X, Solaris, and many others. And yeah, at the UWM, they use package source extensively to install the latest open source packages on their CentOS, HPC clusters, and development servers. And then there's a section on maturity. There's a lot of sections in there. Maturity, flexibility, performance, modernity, quality and security, not to mention as the last item. Collaboration, convenience, and support. Package source is also continuously growing, so they provide a link to a package source growth graph. And it's quite easy to get started. And then they have a small section on getting started creating your own little package for package source. And if it's finished, how to upload that to package source users. So there's quite a bit in that article, and definitely a good argument to look at package managers and know them in and out to actually fire and forget. Just install the packages and then actually do what you want to do with that software rather than spending too much time installing it.
Yeah, and as I said here, the UWM actually provides the binary packages that they've built for themselves available to everyone. So if you're in the research community and need a bunch of these science apps, you can actually use ones that have already been compiled if you don't want to build that infrastructure yourself.
Yeah, and that's the sharing part of the open source world, and that's why we like to do these things.
They also have a link to their documentation for building your own binary packages. So if you don't want to use the one at UWM, they describe their process so that you can build your own as well.
Yes, that's the ultimate next step. Not just using packages from someone else, but building your own packages and then either providing it internally or with some special settings and options that make it interesting for other people as well.
Yeah, it's kind of one of the important aspects of doing real science and publishing with it is you need to give the reader the ability to recreate your results. That's how you prove that your results are repeatable. Well, if you cavemanned your software, then that's a lot harder to describe than, install this version of the software from the package manager for whatever OS you're using, and then do this, and you're done.
Yes, yeah. Important aspect, especially in science, the repeatability. And with that, it's much easier in an open world in science.
So next up, we have a post from Joshua Stein, who says, "Touchpad interrupted." So he goes on, for 2 years now, I've been driving myself crazy trying to figure out the source of a driver problem on OpenBSD. Interrupts never arrived for certain touchpad devices. Well, a couple of weeks ago, I put out a public plea asking for help in case any non-OpenBSD developers had recognized this problem, but while debugging an unrelated issue over the weekend, I finally solved it. It's been a long journey, and it's a technical tale, but here it is. So back in 2015, I purchased a Samsung ATIV Book 9 laptop. Its touchpad was different than most other laptops used in OpenBSD and would be a model for most touchpads to come after it. It was a Windows Precision touchpad connected via I2C. Most other touchpads had a touchpad connected via the PS2 controller along with the keyboard, emulating the historical design of PCs that had two PS2 ports for the external mouse and keyboard. These devices from Synaptics, ELAN, and ALPS each spoke a proprietary protocol and were rather bandwidth constrained in terms of how much finger data they could actually communicate back to the OS, which became a problem when multi-touch gestures became a thing in Windows. For those devices, Microsoft produced a Windows Precision Touch specification and would handle the driver side of things, allowing vendors to have touchpads that share a common driver and worked in Windows out of the box, as well as allow Microsoft to provide better touchpad experience with gestures and palm rejection, but still not be able to rival what Apple does with the Broadcom touchpads in their MacBooks. Back in 2016, OpenBSD got support for this. Joshua finished writing drivers for these touchpads that required an I2C controller device, DWIIC, a HID over or human interface device over I2C driver, IHIDEV, and a basic I2C to HID mouse driver, IMS. Then a fully transport agnostic human interface driver for the Windows Precision Touchpad, HIDMT. And finally, an I2C touchpad driver, IMT, to interface between those two devices. Shortly after, some laptops started showing up with their keyboards connected over I2C as well, requiring the iKBD driver. In 2018, I wrote UMT to support USB-connected Windows Precision devices in use on some other laptops, especially with touch screens. While all of this worked fairly well and somewhat modernized OpenBSD's non-ThinkPad support, since many ThinkPads up until 2019 models still did the PS2 connected touchpad and trackpoint, there was one aspect that didn't work. On the Broadwell and later chipsets, the touchpad would not wake up after an S3 suspend resume. So late in 2016, I purchased a Chromebook Pixel and got OpenBSD running on it. The Pixel also had its touchpad and touchscreen connected via I2C. Though being a Chromebook, it wasn't running Windows, its touchpad didn't conform to the Windows Precision Touchpad standard. And so we worked on that. So after some months of debugging on Linux, I tracked down the fix to a single write to a register in the I2C controller device, which was found in Linux's Intel low power subsystem. In Intel's LPSS, it used for the I2C and SPI devices, used to limit power usage by quickly shutting off components when they're idle. The way this is implemented in Linux is kind of confusing, and even now looking at the main LPSS drivers, I can't see where the 0x800 register comes from that the OpenBSD driver writes to in order to power up this I2C slave device. So, forwarding a bit to 2017, where Joshua purchased one of the Huawei MateBook X's, which is kind of meant to be a work-alike of a MacBook, which has a Kaby Lake chipset, which Intel refers to as the 100 series. Intel's I2C controller on this chipset now shows up as an actual PCI device, which meant splitting up the DWIIC driver for both PCI and ACPI attachments. The driver fetches the ACPI resource information from the I2C slave devices that are connected to it, like a touchpad. That resource includes the slave address and the interrupt pins that will be connected to. The device then attaches and uses the standard method in the OpenBSD kernel to program the IO APIC, a device to register the callbacks whenever the pin receives an interrupt. Despite all of that being set up with the proper address and pin, which matches what Linux did, the IO APIC would never receive an interrupt on that pin, and the touchpad driver would never have its interrupt handler called when the touchpad was touched. It was being properly powered up and would respond to I2C human interface device commands, and if pulled after touching, there was finger data available to read, it just never generated an interrupt to say somebody's touching the touchpad. As with the S3 resume issue, I spent months trying to figure out what was happening with these missing interrupts. I attended the OpenBSD T2K 2017 hackathon and spent nearly a week straight in a room full of OpenBSD developers as I tried tearing apart the Linux I2C, LPSS, IO APIC, and ACPI code, and no luck. As I heard reports from other users and developers with the Intel 100 series machines with the same interrupt problem, I started assuming it was specific to the newer chipsets. I went digging through Intel documentation and the I2C implementation of other OSs, such as Core Boot and Google's Zircon kernel, to find anything related to this specific hardware. Growing weary and admitting defeat, I added an adaptive polling mechanism to the iHiDev device, so the kernel would pull the device every 200 milliseconds until there was touch data available, then pull every 10 milliseconds until shortly after it stopped receiving new data. This was enough to get touchpads working on these new laptops, but it was slow and wasted a bit of CPU time and drained battery power. Unfortunately, that temporary pulling mechanism had to be used for the next 2 years as no one could fix or was interested in fixing this problem.
That's bad.
And sadly, the answer seems to be buried really deep in the code here. But he goes, a few weeks ago, I purchased a 7th generation ThinkPad X1 Carbon. Getting OpenBSD installed and working on it was quite a feat as there were multiple bugs to fix. The first showstopper was that the kernel panicked shortly into the boot on the installer due to the AML problem reporting not an integer when executing a particular method in ACPI. For some quick background, Linux and every other operating system other than OpenBSD and Windows uses the ACPI interpreter called ACPI-CA, which is written and maintained by Intel. But OpenBSD and Windows use their own custom developed stacks. Presumably, Microsoft has many engineers available to maintain their ACPI implementation, and every other OS just imports the one from Intel. Unfortunately, on OpenBSD, this means we have to fix bugs and implement new functionality required by the spec whenever we encounter it. And the cause of the not an integer panic on the X1 was due to some of the AML in this method, and they talk about a bit about that. They say basically for each newer version of Windows that the system reports it is compatible with, OpenBSD reports as being Windows 2015, the operating system is updated to the higher value. The OSYS variable is then used in various other methods related to setting up the devices. As it turns out, the way that OpenBSD's stack was walking the tree, looking for these init methods, is slightly different than what ACPI-CA and Windows does. On OpenBSD, the nodes were being walked in one order, but in the other, they were being walked in a different order. This slight change in ordering was the entire cause of the interrupt problem. Remember earlier when I said I checked the list of INI calls in Linux versus OpenBSD? Well, I did, but I didn't realize that the order would be important or that they had any interdependencies. So when this first one, TPL1 INI, is executed first, operating system is still 0, meaning that conditions mentioned earlier was returning true and executing the wrong stuff. So the fix for this was to change the node walk algorithm to match what ACPI-CA does and execute a matching child node for a device before recursing through its child devices. This way, the operating system version will be set properly. With that fix in place, I'm happy to finally disable that forced polling mode in the DWIIC driver. In the end, the bug had nothing to do with the device being an Intel 100 series and was most likely affecting all of them similarly because all the vendors used the same ACPI template. But these bug fixes are now in OpenBSD's tree and have been in recent snapshots, so if there's bugs affecting you, you can probably just update.
Excellent, yeah. One more reason OpenBSD does things a bit different. And this is the devil in the details in this particular case. But yeah, it's good to see that it's finally fixed and found out where the culprit was. So next up in our news roundup, we have the second evaluation report from porting Wine to AMD 64 on NetBSD. We covered the first part. So this is for Google Summer of Code. They have to provide reports at certain intervals during the program. And this is the second evaluation report here. This is written by Naveen Narayanan, I guess. And the progress encompasses, or the project... the report encompasses the progress of the project this way during the second coding period. So Wine on AMD 64. As getting Wine to work with WOW64.
That's Windows on Windows, I think. It means 64-bit Windows API.
With that support was the foremost importance. The focus was on Compat32 dependency packages with which Wine's functionality would be limited and, more importantly, untestable. Initially, being unaware of what to expect, just wanted to let Wine run at the earliest. So with utmost support from mentors, the consensus was to install libs from 32-bit packages to prefix /lib/32 and ignore everything else that came with the respective packages. So they had most of the Compat32 packages ready after a couple of days. Oh, that's good to hear. And it was time they gave Wine a whirl. Well, the build was successful. However, they had problems with the 32-bit Xorg. The applications which came packaged with Wine worked fine, but other Microsoft Windows applications like Notepad++, Mario, etc. had a hard time running. Additionally, they noticed that font config went wild and crashed, spewing errors, symptomatic of Wine 32-bit not playing nice with the font config lib that came with 32-bit Xorg packages. On top of this, they found that build failed on certain machines due to the unavailability of the headers. This made them reconsider the decision to install 32 bits to the prefix /lib/32 and then ignore everything else, which included headers and binaries.
Yeah, so it turns out you probably need the headers too.
Yeah, it's apparently important. So ultimately, they realized that it was time they found a proper solution to the problem of where 32-bit packages should be installed to NetBSD, AMD64, and then eventually settled on their prefix /emule/NetBSD32. It seemed logical, and it got on with the task of adopting the respective makefiles of dependency packages to install to that directory. And in addition, they packaged fontconfig 32-bit in high hopes that Wine would have behaved appropriately with the former. Wine build was successful. However, they noticed that Wine wasn't linking against the fontconfig libs from the packages, but against the ones which came with 32-bit Xorg package. Later, they realized, after consulting with mentors, that the package source doesn't search for packageconf files, which end with the extension .pc in the /emule/netbsd/lib default. Package source sets package config libdir appropriately based on lib ABI suffix. And as you can see, it doesn't search for .pc files, and hence package config couldn't get the right flags for fontconfig package. On the other hand, Wine configure scripts found fontconfig libs provided by 32-bit Xorg Windows packages, and again it linked to Wine. A kludgy workaround was to use configure args for the respective libs, thereby obviating the configure from finding the wrong libraries. Finally, with the help of the aforementioned kludgy workarounds, they were able to build Wine and successfully run Mario and Lua as a 32-bit binaries. Excellent. They have a screenshot here. Why was it so important to let Mario run? But yeah, I guess this is where the gaming starts. Yeah, so they provide a couple of instructions how to run Wine on NetBSD current for people who want to try it out or help with fixing some bugs or testing it. So you build the current distribution, compile the current kernel with user_LDT enabled and SVS disabled. Then you install the kernel and distribution. Then you clone the work in progress repo. And you go to user package source /wip/wine64 and then make install. And then you export the LD library path user package emule net/netbsd/lib. And then you wind mario.exe or whatever other binary you have lying around. The future plans is that Wine requires the kernel option user LDT to be able to run 32-bit applications on AMD64, facilitated by WOW64. Presently, this feature isn't enabled by default on NetBSD, and hence the kernel has to be compiled with user_LDT enabled. But this also warrants the kernel option SVS to be disabled currently owing to compatibility issues. And work is being done to resolve the conflict, which could apparently allow user LDT to be enabled by default in the generic kernel. Hey, that's good progress here.
Yep, and then talk about solving the problem with package source as well.
Yeah. So it's just finding the right path and prefix. Yeah, and in summary, they basically have that Wine on AMD64 is in a test phase. It seems to work fine with some caveats like LD library path, which has to be set for 32-bit Xorg libs. But the latter is due to extracting 32-bit libs from tarballs in spite of built 32-bit Xorg on AMD64. But package source doesn't search for fontconfig files as mentioned. They were working on these issues during the final coding period and would like to thank their mentors, Leot, Maya, and Christos, for saving them from shooting themselves in the foot many times, and admittedly have had times when multiple approaches, which seemed right at the beginning, then perplexed them, and believed that those are times when having a mentor counts, and have been lucky enough to have really good ones. And once again, thanks to Google for this wonderful opportunity in providing Google Summer of Code.
Yep. And then next, we have another Google Summer of Code update on enhancing Syzkaller support in NetBSD from Siddharth Murali. As part of Google Summer of Code 2019, I'm working on improving the support for Syzkaller kernel fuzzing. Syzkaller is an unsupervised, coverage-guided kernel fuzzer that supports a variety of operating systems, including NetBSD. This report details the work done in the second coding period. So they're actually looking at network packet injection. As part of improving and fuzzing support for the NetBSD kernel, I decided to add support for fuzzing the network stack. This feature already exists for operating systems such as Linux and OpenBSD. So the motivation is the aim is to fuzz the network stack by sending packets with malformed or random data and see if it causes any kernel anomalies. We aim to send packets in such a way that the code pass in the kernel, which would usually get triggered normally during ordinary usage of network stack, would also get triggered here. And this is achieved using the tap/tun interfaces. The tap and tun interfaces are a software-only interface, which means that there's no hardware actually linked to it. This makes it an ideal option to be used in interacting with the kernel networking code. Usage-based programs can create tap and tun interfaces and then write properly formatted data into it, and it will be sent to the kernel. Also, reading from the tap or tun interface would give us that data that was sent from the kernel. So our basic design was to create a virtual interface using tap or tun and send packets through it. We add two syscalls, sys_emit Ethernet and sys_extract TCP res. The former does the job of sending a packet to the kernel, and the latter receives the response. We need the response from the kernel to be read because we need the TCP acknowledgement number to be able to use that in the next packet. So the sys_extract TCP response also extracts the acknowledgement number from the reply the kernel sent. And then they link to an article that explains the concept of TCP acknowledgement and sequence numbers if you need to brush up on that. So then they looked at parallelizing the network fuzzing. In the Syzkaller config, you can define the number of processes that Syzkaller can run on a single VM instance. And since we have multiple instances of the fuzzer executor running at the same time, we need to make sure that there is no collision between the interfaces. For solving this, we create a separate interface for each fuzzer and assign it with a different IP address, both IPv4 and IPv6, to create isolated networks. So executor 1 uses tap 1 and executor 2 uses tap 2, etc. They also played with file system image fuzzing. A very less explored area in fuzzing is file system image fuzzing. Syzkaller supports file system fuzzing only for the Linux kernel. We are currently working on porting the existing support that Linux has over to NetBSD and improving it. The aim is to fuzz the file system specific code by mounting these custom images and then performing operations on those images. This could lead to the execution of kernel components of file system code and allow us to find potential bugs. Looking at the existing design, they said, as I mentioned in the previous report, Syzkaller generates inputs based on a pseudo-formal grammar. This allows us to write grammar to generate file system images on the fly. This is what the current implementation does: generate random images, write the segments into memory, and then mount the resulting image. They also worked on coverage display. Syzkaller has a utility which uses the coverage data from kcov, which basically lets you see which bits of the kernel code are actually getting run by the tests so that you can figure out, oh, I need to change the input to go in the other direction on this if statement so we execute this other code that we've never actually run in our tests. So it uses the coverage from kcov and marks the corresponding lines on source code and displays those again. This feature isn't working for some operating systems. The issue is that Syzkaller is trying to strip off the common prefix on all the file paths retrieved by kcov and then appending the directory where the source code is presented to access the files. And so, on Linux, manager/linux/net/core/sock becomes netsock or netcore sock, and so on. Stripping the common prefix makes sense on Linux since its files are distributed across multiple folders in the source directory. This created issues for NetBSD since almost all the kernel files are present in the source/sys, which leads to the sys being removed from the resulting path, leading to an invalid file name. I worked on revamping the sys manager such that it removes the prefix computation altogether and takes a prefix we need to strip as part of the config for sys manager. Then we add the file path to the kernel source and we get working display of which lines were tested and which ones weren't. So they say the to-do is the file system fuzzing code isn't upstream as of now, but they are working on that. And I've also added basic support for fuzzing both the file system and the network stack. Now there's a lot of improvements to be done to actually test more variants and so on. In summary, so far we found 70 unique crashes using Syzkaller. During the final coding period, I'll be working on improving support for the file system fuzzing. Last but not least, I want to thank mentors, Camille and Cryo, for their useful suggestions and guidance. I would also like to thank Dmitry Vyokov from Google for helping with any issues faced with regard to Syzkaller. And finally, thanks to Google and the NetBSD community for the Google Summer of Code.
Yeah. So I guess we'll be seeing a couple more of these reports once they've been published or finished, actually, from the other BSD projects. This next item that we have is the July update, all about the Pinebook Pro. This is over at pine64.org. They've mentioned last month's update in their blog post that the PinePhone prototypes are currently being manufactured with due in August. Oh, that's right now, I guess. And the PineTap dev kits are rolling off the factory line to be shipped out to developers. With both the PinePhone and PineTap currently in transition to their respective next development stages, they'll devote this month's update solely to the Pinebook Pro pre-order announcement, the last announcement feature of the laptop, as well as a hardware and software status update. There's plenty of stuff, so they have us list them as bullet points here. The Pinebook Pro pre-order starts July 25th, so that's already out. Pinebook Pro gets privacy switches, Pinebook Pro OS builds, battery life, and magical kernel. And Pine64 keycap. So I guess we can quickly go over the Pinebook Pro pre-order, start July 25th. That's already running. You maybe have seen one or have already placed an order. Then they have the privacy switches. So privacy switches on the Pinebook Pro are the last unannounced feature they were dying to talk about for some time now. They had to hold back the excitement and keep the mouth shut because we first had to make sure that our implementation of the switches would work reliably and as intended. And the reason they kept this information back wasn't to be secretive, but rather not to disappoint if the implementation wouldn't pan out and the Pinebook Pro would ship without this feature. With that out of the way, they're very pleased that the implementation worked out because they're very well aware that a part of the draw of the Pinebook Pro is its core free and open source nature, which means respect for both users' choice as well as privacy. So there are 3 privacy switches mapped to the F1, F2, and F3 keys on the Pinebook Pro keyboard. They deactivate the following. First, the Bluetooth and Wi-Fi module. The second, the webcam. And third, the microphone, so no one can listen in without you noticing. They have a broader overview of how the switches work, but I guess this is a bit further. People can read it.
They talk about the launch day support will be for Linux and Chrome OS, but they have a specific note about BSDs here, and I'll just read that. So as I said, I won't be talking about the BSDs, but I feel like I should at the very least give you a general overview of the RK3399 BSD functionality. So I'll make it quick. I've spoken to a number of different BSD developers working on the Rock Pro 64, and from what I've gathered, despite each of the BSDs having varying degrees of support for that SoC, many of the core features are already supported, which bodes well for being able to run BSD on the Pine 64 Pro. That said, some of the things you'd require on a functional laptop, such as the LCD or external display port, for instance, will not work on this Pinebook Pro using BSD as of today. So clearly a degree of work is yet needed for the BSDs to be able to run on this device. However, keep in mind that BSD developers will be receiving these units soon, and by the time you receive yours, maybe this basic functionality will be available.
Ah, great. Then we'll definitely have something. If people have drivers developed or have it running, then we'll have something to cover in future episodes. Maybe we'll see one at a conference that we're going to. Maybe a developer brings one, so we can have a look.
I've been talking to somebody who's built some kind of super cluster out of the Rock 64 Pro.
Ooh.
It's like 100 of them in a 3U chassis or something.
Oh, that's a cool idea.
Okay, next up, we have an interesting post here from Igor, killing a process and all of its descendants.
Ah.
So killing processes in a Unix-like system can be trickier than you might expect. Last week, I was debugging an odd issue related to a job stopping on a semaphore. More specifically, an issue related to the killing of a running process in a job. So here's the highlights that I learned. Unix-like operating systems have sophisticated process relationships, including parent-child, process groups, sessions, and session leaders. However, the details are not uniform across operating systems like Linux, BSD, and Mac. POSIX-compliant operating systems support sending signals to an entire process group, by using a negative PID number. But sending signals to all processes in a session is not trivial, and child processes started with exec inherit their parent signal configuration, because you're basically cloning the process. If the parent process is configured to ignore SIGHUP, then the child will as well. And finally, the answer to what happens with orphan process groups is not a trivial answer. So in his little example, he starts 2 dummy processes just by running sleep and putting it in the background, and then runs pstree, and you can see that init started bash, bash started pstree, and it has these 2 sleep commands running. When you run ps, the command displays the PID of all these processes and the ppid or parent PID of the process. So you can see bash is running with PID 29051, and you can see the 2 different sleeps running as 1470 and 1538, but with the same parent. I held a very incorrect assumption about this relationship. I thought that if I killed the parent of a process, that it would kill the children of that process too. However, this is incorrect. Instead, child processes become orphaned, and the init process reparents them. So let's see the reparenting in action by killing that bash process. The current parent of the sleep commands, when we observe them, switches to init. The reparenting behavior was odd to me. For example, when I SSH into a server, start a process, and exit, the started process is killed. I wrongly assumed that this is the default behavior on Linux. It turns out that killing of processes when I leave SSH session is related to process groups and session leaders and controlling terminals, and not just generic.
Interesting.
So what are process groups and session leaders? So if you run ps and j, you will actually get to see the process group IDs. Apart from the parent-child relationship expressed by the parent process ID, we have 2 other relationships: the process group, represented by PGID, and the session with the SID column. I think these are from Linux. Process groups are observable in shells that support job control, like bash or ZSH or whatever, that are creating a process group for every pipeline of commands. A process group is a collection of 1 or more processes, usually associated with the same job, that can receive signals from the same terminal. Each process group has a unique process group ID. So if you do tail pipe grep, you'll notice that while they have the same different PIDs, they're in the same process group. Whereas other commands you ran are in the same session, but not the same group, but still have the same parent of your shell. And so they have a graphic here that makes it a little easier to understand what's going on.
Yeah.
They also note that not all bash sessions not all bash processes are sessions, but when you SSH into a remote server, you usually get a session. When bash runs as a session leader, it will propagate its SIGHUP signal to its children. The SIGHUP propagates to children was the core reason for my long-held belief that children are dying along with the parents. But it's actually that when it's a session leader, when the session goes away, you send sig hang up to all the children. The idea being that, you dialed in with an old-fashioned modem, and when you hang up, all those processes terminate.
Makes sense. Yeah.
But they also say that sessions are not consistent across different Unix implementations. Watching what it does in System 4 or System 5 Release 4 versus Linux versus BSD can be slightly different. Also, that killing all processes in a process group or a session, you can use the process group ID to send a signal to the whole group. So kill sigterm on negative and then the process group ID, and that will get all the processes in that group. Say killing all processes in a session is quite different. As explained in the previous section, some systems don't have a notion of a session ID. Even the ones that have session IDs like Linux don't have a system call to kill all the processes in a session. You need to basically walk the /proc tree and collect all the PIDs of all the processes that have the same session ID. Although pgrep provides an implementation for this, so you can use pkill-s session ID. And they talk a little bit about using no-hup so that a program won't die when you disconnect your SSH session.
Yep, no hang up. Yeah, so that's interesting to know with the session leaders. That's not a concept that's been taught so far that's very visible or very known. Okay, yeah, definitely read the rest of the article. And then we have for you fast software, the best software. On the benefits of speedy software and how it affects user perception of engineering quality and overall usability. So this essay on craigmod.com goes like this. I love fast software. That is, software speedy both in function and interface. Software with minimal to no lag between wanting to activate or manipulate something and the thing happening. Lightness. Software that's speedy usually means it's focused. Like a good tool, it often means that it's simple, but it's not necessarily true. Speed in software is probably the most valuable, least valued asset. To me, speedy software is the difference between an application smoothly integrating into your life and one called upon with great reluctance. Fastness in software is like great margins in a book. Makes you smile without necessarily knowing why. Some of the most used, most speedy pieces of software is NVAlt. It's an oddly named, very bland software, just a database of plain text files with a plain text editor bolted on. But it's fast, the fastest piece of text cataloging software I've used. It opens instantly and produces results instantly. My NVAlt database is full of tens of years of notes. Open it and your cursor is already in the search field. It is keyboard-friendly software. If you have ever not in the search field, just hit escape and you'll land there. Type a few letters and all of the notes with those letters appear. It is the best instantiation of an off-board brain I have. Any piece of text with value in my life gets dumped into NVAlt. And that syncs with Simple Note. This is handy because NVAlt is macOS only, so you can use the Simple Note iOS app to keep your extra brain nearby on the go. Simple Note also has a macOS app. You may think, why not use the Simple Note desktop application? Because it's not quite as fast. We're talking milliseconds, but it's enough that you feel the difference. It's the difference between $1,000 Japanese garden shears and $150 garden shears. They both cut just fine, but if you work in the garden all day, you will probably feel the difference. And then they have other examples of software they're using and their speediness. And yeah, it's definitely worth a read, combining and comparing these tools and looking for the speed in them and making you productive, not making you wait just to get something done.
Yeah, I definitely know what you're talking about. Like, for example, he talks about Sublime Text. He feels it doesn't slow down when you throw really large files at it, like 50,000 lines. And I've definitely found that with my text editor, there are some files that I won't try to open in other editors because they'll just choke on it. Whereas, if I feed 100,000 lines of something to this app, then it works fine.
Yeah.
Although the app I did like, Komodo Edit, does very well unless you feed it a giant docbook file. Because it parses all the XML, and our docbook is just so XML heavy that it can chug for a couple of seconds as it builds this render tree of all the XML.
Yeah, it probably validates this as well.
Yes, and it does nice stuff. Like when you start writing the XML, it like puts a closing tag behind your cursor, so like you don't forget it, or it auto lines them up when you're doing tabbing. It's all very nice, but it does come at a cost.
Yeah.
And sometimes you would just rather your editor was faster.
Yeah, I just want to edit this text. Why does it take so long? They also have some negative examples there, like iTunes or Google Maps. They are also saying that it's dying a tragic public death by 1,000 cuts of slowness.
Yeah, so Adobe Lightroom and Photoshop do not feel like a fast focus tool. At one point, they did, and that's why I chose them. But Photoshop in the 90s was very fast, and recently I needed a tiny like 16 by 16 pixel orange square, and so I farmed that task out to somebody else in the house who has Photoshop and so on. And it took them longer to launch Photoshop than to make the image. It's like, yeah, Photoshop takes too long to load.
Yeah.
Yes, they say Photoshop is now a turkey. Just opening the new file dialog takes seconds to create a new blank file. In 2019, if you press Command-Option-Shift-W to export an image, it takes 3 to 5 seconds to load that screen. And if you accidentally press Command Option W, it closes all your windows.
Yeah, closing is always quick.
Yeah. Command Option W closes everything. Command Option Shift W exports the image. Those seem too close together.
Yeah, there's a lot of mistypes there that does the wrong thing that you didn't intend. Yeah, we've all been there.
But why is slow bad? Fast software is not always good software, but slow software is rarely able to rise to greatness. Fast software gives the user a chance to meld with its toolset, that is, not break their flow. When the nerds hit Nerd Hill, fight to the death over VI and Emacs, is partly because they have such a strong affinity for the flow of the application and its meldiness. They have invested. The tool is good, so they feel. Not breaking flow is an axiom for great tools. I definitely, for a long time, it's why I like desktop applications over web ones, because the web one would have even this minutish delay between each action while you were just waiting to go to the web server and come back or whatever. And it's why I don't like having animations in my software. It's like, that's just slowing me down. Stop it.
Yeah, it's looking nice for a few minutes, but then afterwards it just gets in the way. And keeping software quick and fast to react to user input is always a challenge as you add more features and it becomes bigger and bigger. All right, time for the Beastie Bits this week. We should definitely nag you about registering again for BSD conferences. The first is VBSDCon in September, the first week of September 5th to the 7th in Reston, Virginia. It's only every other second year. So this year, why don't you go there and hang out with us?
Yeah, so if you're in North America, this is your conference for September. And hurry up and register because the early bird is running out. And once it's out, you'll have to pay more.
And no one wants that.
But we hope to see you there. We'll both be there. So
definitely, yeah.
Hi.
Good opportunity to shake hands with your favorite BSD Now podcasters. I'm not sure. And or watch the talks in the conference. There's definitely something interesting there for you. The second one is EuroBSDCon in September, just 2 weeks away from VBSDCon. So you might as well hitch another ride to Europe. September 19 to 22 in Lillehammer, Norway. It's this year. And it's always interesting, 2 days of tutorials and 2 days of conference. Or if you're a developer, then you can ask to get an invite into the developer conference or the developer summit. I guess FreeBSD has one. Definitely, I'm organizing that. And also NetBSD had one, I think, in the past. So they've also...
it's not on the schedule this year. I don't know.
Not yet? Okay.
But yeah, yes. If you're from Europe, it probably makes more sense to go to EuroBSDCon.
Yeah.
Or you can be crazy like us and go to both. But, I'm not sure I advise that. Either way, we'll both be there. So nobody has any excuse not to say hi to us at some point at one of these two conferences. And we hope to see you there.
Say hi. And if it's your first BSD conference, both are good introductory conferences into the BSD ecosystem.
Yes. And either way, if you attend one of these conferences or if attended another one, we would love you to write in a trip report. We find that hearing about other people's experiences at the conferences is one of the number one ways to get new people to give it a try.
Yeah, because people have similar experiences when they're new to something or not kind of sure what to do or how to interact with people, but that's fine. It's just breaking the ice. And if you see how other people did that, then it's easier for you to follow that. All right, time for feedback and questions. Last episode, we nagged you that you should send us feedback and questions, and some people responded, but there could be more. So everything that should be in this section should be sent to feedback@bsdnow.tv. And any question that you have about the BSD, something that's not clear, something where you struggle, this is where we help you, or at least try. The first one this week is Paolo with a FreeNAS question. And Paolo writes, "Hello, Benedict and Alan. I have a quick FreeNAS question for you. I have been struggling with some CentOS NFS clients connected to FreeNAS using NFS v4 over TCP. Mount sometimes works right away, sometimes takes a while, 2 minutes roughly. Same for listing directory contents or checking DF on an exported dataset. I do not experience the same when the NFS client is another FreeBSD box. I also do not see any relevant message on Warlock messages or a daemon. Question is how to enable extra verbosity or a debug level on the NFS server itself. I couldn't find any knob on the GUI itself, and I would like to explore an easier way before doing TCP dump. As always, thank you for the great show.
I don't know. Like, part of it might actually be you want to look at the client side first. The 2-minute delay almost sounds DNS related to me. See if using IP addresses for everything makes that suddenly change.
Some caching.
Yeah. Well, not so much that, is just, yeah. dtrace is probably one way to go and is available on the FreeNAS there. Because I don't know that there's much logging you can get NFS to do. Like, I think you might end up having to like compile a debug version of the kernel, enable NFS debug or something, and that's an especially tricky thing to do on a free NAS because it's quite a modified and stripped down version of FreeBSD. But it is odd that the problem doesn't manifest when you do a FreeBSD client.
Yeah, it must have been something Linux.
Not necessarily. There can be a number of different reasons why that would happen, but that's why I would also look at if you can get more verbosity out of the NFS client on CentOS. The other option to look at on CentOS is there's a different NFS client, Ganesha or something it's called, and see if using that client on CentOS gives you different results.
Oh, interesting. Haven't heard about that.
We've talked about it on the show once or twice.
Because I have similar experiences, not as bad as 2-minute delays, but sometimes listing some like home directory contents that also exported from our NFS ZFS server is sometimes a bit slow, but again, only on Linux, not on the FreeBSDs. Maybe someone else has experienced that.
Maybe somebody else knows more. I don't have much experience with having to use Linux.
Yeah, that's a positive thing on your part. Yeah, but that Ganesha thing looks interesting. Maybe that will help at least a little bit, or put it away completely. So if someone knows an answer to that, send this to us, and we'll mention it in a future episode, and then everyone is helped. Okay, so thanks, Paolo, for that question. Next up is Mark with a question about changing VT without the function keys. Mark writes, hey all, on Linux I can use the chvt command to switch what VT I'm on, virtual terminal. If I'm on a keyboard without function keys, yes, they exist, or on an older keyboard that only goes up to F8. Since FreeBSD seems to want to launch X on VT9, you can see how this could be a problem. Where's the key that I should press? How does one change VTs from the command line?
I don't know. It's a decent
Is there a
question.
bit control or something?
So someone making a chvt command for FreeBSD would be very helpful. For the VT9 thing, if you edit etc ttys, you could reduce the number from 8 to 4 or something, and that would move the X1 to VT5, and that might solve the problem if you just have the F8 problem. But a command line way to do it would be very useful. One might exist, but I don't know what it is.
Yeah.
And if not, somebody making a CHVT seems super useful. Even in cases like with what I'm doing IPMI and stuff, sometimes it's just you have to end up using the mouse and the virtual keyboard or whatever to send some of the control characters, and being able to just type CHVT4 would be super useful. I would be interested in that existing if it doesn't already. So if anybody knows the answers, please write in and tell us. And if somebody's looking for an interesting but small project, well, I can't guarantee it's small, but yeah, somebody making a version of CHVT for BSD would be great.
Or there's something in the ports collection that we haven't found yet. Could be a thing. So
yes, if you know the answer, let us know. And if not,
start coding. Yeah, it's definitely something that you could, there's something to learn there about VTs and how it all works with the keyboard. Nice project. Okay, so next is Caleb with a patch, update, and upgrade management. Always important to know. Caleb writes, "Hi Benedict and Alan. First, I'm not an audiophile, but with the recent changes, I have noticed you guys are sounding better than ever." Yes, we got a little bit of an upgrade there, so that's good that it's becoming popular. Okay, I'm writing today to ask what tools and processes you use to keep your FreeBSD server fleets up to date and running. As a long-time listener, I'm familiar with ports, package, and FreeBSD update, but what do you do to scale those tools across hundreds of thousands of machines? Is there something special you do to avoid a message with Merge Master or an interactive one? Do you try to be ready to patch the latest vulnerability at a moment's notice? Other ideas, tips, or tricks from across the BSD landscape?
Yeah, package itself has good support for a not interactive mode. That makes it pretty straightforward to run, package upgrade -y on machines with headlessly, and it works. I also often tend to do package upgrade capital F, small FY, which will make it download all the packages but not install them. And I can like cron that or whatever. And then when I go to actually do the upgrade, it's only the installing part, not the downloading part, which can be really helpful. At work, we don't use any ports. We do everything with packages. We build our own. So we basically customize our packages to be what the port would be. And so we just force install those and it works great. And recently we switched away from using FreeBSD Update to using Poudre image. And so we actually create a ZFS boot environment of the new version of FreeBSD. So on our builder, we have one FreeBSD jail that Poudre manages, and we use FreeBSD Update to update it. And it's basically an empty install of FreeBSD with nothing touched. And then we update it, and then we basically ZFS send that, or we install that to an empty ZFS dataset, and then we ZFS send that to our servers, and then they reboot onto the newer version and upgrade complete. To avoid the merge master stuff, what we ended up doing was creating a separate dataset called /CFG that contains the 10 files in etc that we modify, and the rest of the files in the image that we deploy are stock FreeBSD files, and the 10 that we modify are symlinks to the version in /CFG, and we just ship that way.
Ah, yes. Yeah.
But we don't recommend that for everybody. That's more of our, when you have hundreds of machines, it can make more sense to do it that way. If you don't modify very many files, the FreeBSD update or merge master stuff shouldn't hit you very often. The only time I've really had it, squawk about every file ever is when I've changed versions or branches or something. When I'm tricking FreeBSD update to upgrade, a stable version to the release or something like that.
I also have to consider whether the machine is currently in use, because let's say if there's a FreeBSD security advisory coming out and I cannot restart our Postgres server right away because there's currently a lab going on this one, and the professors are always a bit upset when the main machine goes down during a lab. But then I have to schedule it for later in the day or at night so that they install the packages and don't reboot until a certain time. Do you have some kind of a patch day, Alan, where you specifically patch days or machines at a certain day?
FreeBSD doesn't have something like that currently. They just come out as quickly as possible.
But internally, in like the company?
At work, we don't really have something like that, but we do end up scheduling them. Just they're not necessarily on a certain tempo. Mostly because we have to avoid our customers doing video streaming have events that happen, things like every Tuesday or something. So if we defined a policy of the first Tuesday of every month, we would interrupt that same person on a regular basis, and that would cause a problem. And so we try to stagger them so that they don't happen repeatedly at the same time, so that we don't keep impacting any one customer more than our other customers. So usually late at night when nobody's doing anything works for us, but that is inconvenient for our staff sometimes as well.
Yeah, and if you have a worldwide operation.
The other upcoming stuff is there are two different projects two different versions of a package base, one based on the source tree and one based on the ports tree. Those both provide a nice way to be able to update the OS using the package tool, which can be very handy. So package has some support for dealing with the config file problems. So it will do a three-way merge on the config files to keep your changes but update the template. If it fails at that, it will install the new one as a .new and give you a list at the end, and you're expected to go deal with them later, which mostly works unless something in an application changed significantly, which doesn't really happen in the base system. So it's less of a worry than when with, say, ports. And so, yes, the packaged base system is one of the ways forward that maybe will be nicer.
And Alan gave a talk about this Poudriere image at one of the EuroBSD cons.
Yes, I did a EuroBSD con last year in Romania, but that wasn't recorded. But I also gave that same talk at FOSDEM, where it was recorded. And did I talk about it at Euro as well? Yes. Yes, I have the slightly more detailed version and slightly more oriented to making appliances or managing a fleet of servers is from AsiaBSDCon, and the video's there. Or there's the version from FOSDEM, which is geared a little bit more towards like your laptops and home servers, depending on the scale of how many computers you're doing. But
if someone else has a different strategy or another kind of management, then also mention this. Send this to feedback@bsdnow.tv, and then we'll discuss certain approaches, pros and cons.
Yes. My immediate reaction is, what does Dan do?
Yeah, that would be one person to go to.
At work. And I think the answer is FreeBSD update, but I'm not sure.
But he also may have some interesting ways of updating, not everything at once, but in like seeing if the update works and then at other machines.
One of the things I really like about FreeBSD is being able to separate the updates of the operating system from the updates of the applications. And mostly, I trust the operating system updates not to break anything, so I just do those as soon as they're ready. Whereas jumping to newer versions of applications means, I need to deploy that to a dev environment first and play with it. So,
all right, that pretty much wraps up our episode this week. Thank you for listening, as always, and listen to us next week.